Hello, Year 11, and welcome to our first video here for our third topic, and I suppose the first video for our extension work. We're looking at polynomials here. Polynomials are a type of function where we have positive integers for the exponents or the powers of x. Okay, just positive integers there. Moving along here, let's have a look. Right, we'll explain it as we go along. I have a polynomial here, 3x to the 7 minus 2x to the 4 plus 2x cubed plus 5x squared minus 3x plus 1. There we go, that's a polynomial. All those powers are positive integers, right? 7, 4, 3, 2, 1, and I suppose 1 to the power, 1 is just x to the 0. Yeah. So, we've got those things there. They're written in descending order of power. So the 7 is on the left. That's fairly typical. It's still a polynomial if it's not written that way, but that's just how we tend to write them. Now, the degree of that polynomial is the highest power, right? The largest exponent. That's a 7. That's a polynomial of degree 7, like that. Is it a monic polynomial? Well, think to our quadratic equations. What's the difference between a monic and non-monic quadratic? It's the coefficient of the x squared term, or if you like, the sort of the first term, the term with the highest power. If it's 1, it's monic. If it's anything else, it's non-monic. This is a 3. That's not a 1. So, no, that is not a monic polynomial. State the leading term. Well, the leading term is all of that there, the coefficient and the x term. So it's 3x to the 7. That's the term with the highest exponent. What is the constant term? The constant term is here at the end is 1. Right, that's constant, doesn't have an x in it. Find the coefficient of x to the power of 4. Simple enough there. Is negative 2. Just be careful that you don't miss any negatives there. You don't just go 2. There we go. There's some language around polynomials. We're halfway through this. Now, adding and subtracting polynomials. I might be exaggerating when I say half. We've got a little bit to do. But we can add and subtract these. If I add p to q, or polynomial, p of x to q of x. If I add those together, I take all of the terms in p and add them to all the terms in q. I suppose the most efficient way to do this is just going to be work our way along. The first polynomial here has a degree of 4, the second has a degree of 3. So let's just add all the powers of 4 first. I've just got x to the 4. What about powers of 3? There's nothing here, there's 2 here, so plus 2x cubed. Squared terms, 5x squared plus 3x squared, so negative 5 plus 3 is negative 2x squared. Now adjust our x terms. I've got a 3x and a negative x. So when I add those together, I'll get plus 2x. And finally, my constants, I've got a negative 6 plus a 1 is minus 5. There we go. That's the polynomial p plus q. Now, if I do q minus p, that's all the terms in q, and subtract all the terms in p. I'm just going to drag this over here a little bit. And, well, I've got to be able to see what's going on. So q first minus the p of x. So I'm going to subtract x to the power of 4. There's nothing to take that away from q of x, but that means I'm going to start off with negative x to the power of 4. Okay. Then I have plus 2x cubed. Remember, we're subtracting p of x. Now my x squareds, I've got 3 minus negative 5 is the same as 3 plus 5 is plus 8x squared. I've got a negative x minus 3x, so that is minus 4x. And finally my constants, 1 minus negative 6 is plus 7. There we go. So p of x plus q of x, p of x, oh, q of x minus p of x. Right, like that, adding and subtracting polynomials. Maybe it rings some bells from when we were solving simultaneous equations. Okay, similar sort of ideas there. We can multiply polynomials as well, and this actually does become something a bit new and something a bit more important. So what we need to do here is we need to use the distributive law. Now, this will take a little while. So we'll have to be fairly careful here. It's not just a matter of pairing up the same powers. No. So the p of x times the q of x, I've got to do this, x to the 4 minus 5x squared plus 3x minus 6 brackets. Then I've got 2x cubed plus 3x squared minus x plus 1. Right, distributive law, and off we go. X to the 4 times 2x cubed is going to be 2x to the 7. Remember, we get the powers. X to the 4 plus 3x squared is 3x to the 6. X to the 4 multiplied by negative x is negative x to the 5. X to the 4 times 1 plus x to the 4. Now, continuing along, I'm going to have to zoom out a little bit here, fit everything in. Now, negative 5x squared times 2x cubed is negative 10x to the 5. Oops. X to the 5. Negative 5x squared by 3x squared is negative 15x to the 4. Negative 5x squared times negative x is 5x cubed. You can see I'm rapidly running out of space here, aren't I? I'm going to have to just sort of continue along. It gets pretty scrappy, but it's just going to be how it is. Negative 5x squared times 1 is minus 5x squared. Continuing on here, not the neatest work. 3x times 2x cubed is plus 6x to the 4. 3x by 3x squared is plus 9x cubed. 3x by negative x is minus 3x squared, and 3x by 1 is plus 3x, and one line to go. Minus 12x cubed minus 18x squared plus 6x minus 6, and now we go through and collect our like terms, equals 2x to the 7. Now x to the 6, I'm going to take a different colour here and cross that out. Now, I've got 3x to the 6, that's all. So plus 3, oh no, actually that's going to be nuisance, isn't it? Plus 3x to the 6. Now, x to the 5, I've got a negative x to the 5 here, minus 10x to the 5, so that gives me minus 11. X to the 5. Get rid of those ones so we don't miss them, or think that we've already dealt with them. Now we've got x to the 4s, and we've got a few more of these. Okay, they start to group up in the middle. So, 1 minus 15 is negative 14. Negative 14 plus 6 will be negative 8. Right, okay, minus 8x to the 4. Right, we get the 1, the negative 15 and 6. Now the cubes, I have 5 plus 9 is 14, minus 12 is 2. So plus 2x cubed. Back to the blue here. Right, we've got rid of those ones. Now for my squares, I have negative 5 minus 3 is negative 8. Minus 8 minus 18 is negative 26. 26 x squared. Don't worry, you don't have to do this very frequently. I hope I got all of them there. Now for my powers of x, I've got 3x plus 6x plus 9x. Right, nearly done. 3x and 6x. It's really disappointing when you get to the end and you go, oh yeah, look at that one there. I haven't had that on. I've got to rewrite it all again. Minus 6. Okay. Whew, what a mission that is. Like I say, you don't have to do it terribly often. So, yeah, look, you just use the distributive law if you multiply these together. It's not common that you're going to multiply together a degree 4 and a degree 3, but a 1 and a 2 or a 1 and a 3 or something. That's pretty common. Okay, but you don't end up with nearly so many terms to collect. When we have identically equal polynomials, that means that the coefficients are the same as we go along as well, and that allows us, as we get towards the end of this video, that allows us to match them up. If we know they're identically equal, so we use this sort of triple equal sign here. If I know that's the case, then I compare them up. What does that mean? Well, in this example here, if we expand that expression, Right, I'm going to see if I can do it a little bit faster this time. We expand this expression, then we can equate the coefficients. So I've got a 3x by x will give me 3x squared times 2x squared will give me 6x to the 4. Now, oh no, actually that's not going to work that well. Hang on. Okay, yeah, as you can see here, when I expand that out, I get 6x to the 4 minus 18x cubed minus 3x squared plus 9x. Now, if I know that's identically equal to ax to the 4 plus bx cubed plus cx squared plus dx plus e, then a equals 6. Okay, because a will be the coefficient of the fourth term, fourth power. That means that b equals negative 18. C will equal my squared term. C equals negative 3. D equals 9. And E equals 0. Okay, because there is no constant. All good? Rightio. So that's how we operate with identically equal polynomials, and sometimes that gets us out of a bit of a fix too. So quick recap of the video here. Polynomials, the leading term is the one with the highest power. That's the first one, typically, the one on the left. Monic and non-monic, that's fine. The leading term, the degree is the highest power. We can add and subtract polynomials. We can multiply them. We can divide them. But of course, dividing is harder. And we'll get to that later on. Okay, that's it for the first video. If you've got any questions, jot them down. Let me know. I'll see you in class.